Example 1. In example 1, we're going to look at shapes that have square cross-sections. A pyramid 3 meters high has congruent triangular sides and a square base that is 3 meters on each side. Each cross-section of the pyramid parallel to the base is a square. Determine the volume of the pyramid. And just to get a visualization of what's happening, this is what it looks like. Here's a pyramid with triangular sides and a square base. Now as we move the plane back and forth, we see that each cross-section made right here is a square. So what we need to do is at any point x, say right here, we need to determine what is the area of the square. So step 1 is to sketch the shape. After you sketch the image, it's important to label what we know. So we know that the height of this pyramid is 3 meters, and we know that the width of the square base at the bottom is 3. So here is 3 meters, this is 3 meters, and the height from here all the way down to here is 3. So what we needed to do is to determine the area of any cross-section. So I'm going to call this point right here x, which means that this is an x by x squared. Step 2, a of x is equal to the area of each cross-section. And in this example, each cross-section is a square. So a of x is equal to x times x, which is x squared. And if we go back up to the example, and I highlight one of the cross-sections, you can see that the area of one cross-section is a square. Step 3. Determine the limits of integration. We are taking cross-sections as we move up the height of the pyramid. So because of this, the limits are from 0 to 3. And step 4 is to integrate. So the integral is actually the easiest part for volumes. It's just the integral from 0 to 3. And then our function of area, which is x squared dx. And then all we need to do is integrate. So this becomes 1/3 x cubed from 0 to 3, which is equal to 27 over 3 minus 0 over 3, which is equal to 9. And then the important part is the units, 9 meters cubed. And that's it. So now on your own, I want you to try to determine the volume of a cone that is 5 meters tall and has a circular base. And I want you to determine the volume of the cone. So if you think you can do this on your own, go ahead and pause the video and try to draw it and then find the volume. Alright, let's see what we got. So step 1 is to draw it. So after you've drawn the image, it's important to label everything. So notice that right here we have a radius, and right here is the radius. Now as you come out in the cone, the radius of the circles will get larger. And right here at this point, since our height is 5, we can determine the radius of the circle. In this example, we're also using that the radius is equal to the height of the cone. So the radius here is equal to x, since this height is x. So at the bottom of the cone, the radius would be 5, since the height is 5. So what we need to do is determine the shape of each cross-section, and we know the cross-section is a circle, and we need an equation to find the area of each cross-section. Well, we know the area of a circle is pi r squared, And so the area of my cross section, since we're letting r be x, is pi x squared. And this is since r is equal to x. We also know in our problem that our height is equal to 5, which means our limits of integration are going to be from 0 to 5. And then we take our area formula and we put it right here, and dx. And then all we need to do now is just integrate that function. So what we do is it's going to be pi, the integral from 0 to 5 of x squared dx, which is going to be pi times 1/3 x cubed from 0 to 5. So we get pi over 3 times 5 cubed minus 0 cubed, which is going to give us 125 pi over 3 meters cubed.